I'm going to go a little bit through the computer science program, tell you really briefly about it, and then we'll get into what my research is, opportunities that work with me. Professor Shuo Nu also will do that, and we'll get back to our student panelists. If there's anything people want to know, feel free just to kind of interrupt. All right, so the computer science major, basically worldwide, computer science has become one of the most popular majors in many universities, and everywhere we've seen enrollments double or maybe even triple. So it's sort of important if people are interested to know what the requirements are coming in, even though at places like Clarke, you don't need to declare a major right away, and you don't need to come in knowing a major. So our computer science major has a sequence of courses, and so it starts with a one-year introductory course sequence. So we have a course called CS 120, which is our introductory course, and then a CS 121, which is what we call data structures. So after the first year, what people usually would then start taking is some of the 4 core courses, including assembly language and computer organization, an algorithms course, a programming languages course, and an automatus theory course. One of the reasons that I really wanted to emphasize knowing about what the requirements are is that you first need to take these introductory courses, and then you need to take at least one of the core courses. And typically, people need to take the algorithms course. And so if you start the first year with the introductory courses, you can take the core courses in your second year, which then leaves you more opportunities for your 200 level courses. So the major requires 4 200 level computer science elective courses. And these courses rotate every year, oftentimes on an every other year basis. So for example, I teach courses in computer vision, I've taught courses in networks, I've taught courses in databases, as those 200 level courses might be offered every other year. If you start your first year, then you'd be able to make sure you can pick whichever of those courses you want during your junior and senior year. If you were to start your sophomore year, chances are you wouldn't be able to start taking 200 level courses until the second semester of your junior year, and that would give you maybe less choices, okay? So this is why we like to hold these kind of information sessions. We're really open to chatting with you about the opportunities and the possibilities. We really want to get first year students into that introductory course, okay? So sometimes students feel worried about showing up at the university and asking a professor like, hey, I want to make sure I get in your course. If the course looks like it's starting to fill up, or if it's filled up, drop us a line and we want to help you out, right? So as a first year student, you're actually really important to us. You're more important to us as a first year student than a senior is. And don't tell the seniors, right? I'd rather have the first year students in my introductory course than have a senior, because a senior taking intro CS can't be a major because it's too late for them, but a first year student might be a major. And that's the other big point. You don't have to pick. We try to make our introductory course really accessible so that it's useful for people who definitely want to be majors, but it's also useful for people who just want to get a feel for what computer science is about. So many times people will take intro CS just to get a feel for it. And then sometimes they'll say, oh, this is really interesting. Let me take the next course. And then they take the next course. And turns out they like it. And so they major in it, or they end up being a minor. And so maybe some of our panelists were in that situation. They can tell you about it. The other co-requisites, there's 3 math courses you would have to take. So you do need to take calculus. We encourage people to get calculus kind of done the first year because it sets the foundation kind of mathematically for some further courses. There's a course called discrete math that gives you another chunk of mathematical background. So we can tell you about those things, but the main thing I really want to get across is come take intro CS, and we'll see how it goes from there. All right, so those are academic requirements for the major. We also have a CS minor. So the CS minor has the intro sequence, so it starts out the same way, and then you take 4 more courses beyond the intro sequence. So it's 6 courses total. At least one of those courses needs to be at the 200 level, and you can use that discrete math course as one of those options as well of the 6 courses. So what's really nice about the minor is you can start taking the intro sequence, say, hey, I don't know if I'm just taking this one course, if I'm taking this maybe to be a major, maybe to be a minor. You can make that decision as you go, right? As you take the first course, the second course, even the third course, you might decide this is what I want to do for a major, or maybe it's just what I want to do for a minor. The last program I'm going to tell you about is our new data science minor. So we only started that this year. So fall 2019 is the first year we've been offering it. We had the first course in it last fall, and then we offered it the first intro course, the DS 125 Introduction to Data Science, again this semester. And it's been very, very popular. So what's really nice about data science as a field is it lets you do really interesting things where it's not necessarily you're sitting there doing computer science coding, right? And so we can explore essentially what kind of information can you get out of data. And there's so much data around everywhere now that the minor, either in combination with computer science or standalone as a combination with some other majors, psychology, philosophy, whatever. There's data in all of these fields, and essentially understanding how you can analyze data and understand trends in data is useful in almost any field. So the data science minor, you need a year of calculus. There's a linear algebra course, so you typically take that after calculus. That gives you some nice background, mathematical background to understand things like regression, linear regression types of things like that. Take the introductory computer science courses, and then there's 2 data science courses. So if you notice, the way you began all 3 of these programs starts with Intro CS and Calculus, and then you can decide what directions to go with. So there's a lot of opportunities to choose a direction, change it up as you go, get a feel for things, see how you like it, okay? And Professor Han is actually and Professor New are more experts in the data science courses. They've been teaching them, so if there's questions that pop up, we can have them help answer. Let's see, and I hid my chat window somewhere, so if people are typing in chat, then I can't see it. Maybe one of you can interrupt me if you want. So let me just tell you about why. I'm going to try to be brief, right? So I'm used to doing a 75-minute class, or I might have to talk a lot, but I'm going to try to talk less. So why CS at Clarke in particular? So Clarke prides itself on being kind of a small school that offers big opportunities, okay? And in the computer science program in particular, we like to make sure that all of the students have opportunities to get to know the professors, to work with the professors, feel like you can drop in at a professor's office and you're not going to be said like, go away, I'm too busy. So when we do hiring, like so Professor Nua we hired this year, one of the things we were looking not only at his credentials, but are people going to be able to drop in his office, right? And it's like, yeah, okay, so that's why we choose faculty that are welcoming to students. Okay, so the faculty are really eager to work with undergraduate students. We don't have a PhD program in computer science, so our focus is on undergraduate research in computer science, right? Or sorry, undergraduate education in computer science, and involving undergraduates in our research projects. And then we'll tell you a little bit about that, okay? We like to be friendly, right? So I don't know if I wouldn't say the physics and chemistry people aren't friendly. I'm sure they're very nice people, but we're supportive, right? So we want people to come in and ask for help, right? So there's not so much sink or swim here. We're not throwing people into the deep end of the computer science pool and saying, can you code your way out of this problem? If you can, you succeed, and if you fail, then you're failing. We don't work that way, right? We have a lot of TAs in our courses, and the professors are very often available to help people through problems. And we want to do is make you better problem solvers. Okay. we have a great academic program, right? So there's a lot of rigor in computer science. And one of the things you noticed about my emphasis on starting the intro sequence, so you can get to the core ones, so you can get to the high level electives, is that the topics build on each other. So by the time you get to those high level electives, you're using things that you have spent a few years learning, right? And so there's a lot of rigor in the academics that goes along with the support, okay? Our students coming out of CS are getting great jobs at some of the best companies. They're going to graduate programs at some of the best graduate programs. And so even though we're not sink or swim, we still want to make sure that when you graduate with computer science at Clarke, you're able to compete with any other computer science person going for those same jobs at those same graduate programs. There's lots of flexible combinations. So there's popular double majors. People do computer science and math, which is all in our department, but we see a lot of computer science and physics, computer science and biology. I've had a few computer science and philosophy, computer science and music, computer science and studio art, which all lends to interdisciplinary problem solving, right? And so when you come out of Clarke as a computer science major or a double major with something else, what you want to be able to promote yourself as is, hi, I know how to solve these interesting problems in all sorts of fields and all sorts of areas. And that might include something that you don't think of as typically mixing with computer science. Let's see, I'm just checking my slides here, right? So the Clarke resources and support for student career preparation. So we do things like mock coding interviews, and so sometimes these are run by the CS clubs, sometimes they're run with professors. Clarke has a career connection center and a student success network, and they're really eager to have people come in and say do a resume review, right? So you bring your resume in and they check things out. Check out your cover letters. You know, they're going to help you with these things. Check out how you sell yourself in an interview and all of these useful things for career preparations. One thing I've been told by talking to those career connections people is they say the computer science students are the best ones, and they love when the computer science students show up. And for some reason, I don't know if it's because we tell our students to do it, but they say CS students are the best ones at the Career Connections Center. So it's kind of nice to hear that. So there's lots of student opportunities. Many of our students become TAs in our courses. So, you know, once you take that intro CS sequence, the next year you might be a TA as a sophomore in our intro CS course because you took it the previous year. I'm not necessarily looking for the straight A student when I hire a TA. I'm actually might be interested in someone that was a B or a B minus because they figured out how to work through problems and how to you know, overcome difficulties, and then can help the next group of students overcome those difficulties that they encountered. And in doing so, it solidifies your own learning of the material. So there's RAs, research assistants, and so I have students working with me on my research projects. Professor Nuo as well will tell you about that. We run our own computer lab with Linux servers, and we have students as system administrators for that. There's project assistants in the Math CS department for all sorts of projects that are either student-driven or driven by you know, things that the professors are working on. So many times, actually, we have students come in and say, like, I had this great idea for a project, and we say, great, let's work on it. You know, we can set up a directed study. We can figure out what kind of direction you need, what kind of help you need, and student-driven projects oftentimes are more interesting than what the professors decide they want to work on. We have teaching assistants and research assistants in other departments on these interdisciplinary projects because problem solving goes across into any field, right? So using computer science to solve problems in any field is really useful. We have active student clubs. There's several student clubs, and we're going to hear from the students about that. They do things like programming competitions, hackathons, and go to research conferences. So some of the student outcomes, just to show where our Clarke CS graduates have gone recently. So Amazon, Bloomberg, MITRE, Wayfair, Raytheon, big companies. Oh, Google's in there. Shouldn't forget them. Google and Facebook, right? So big companies that our CS graduates are able to compete for these jobs and do well. They compete well for these jobs. Um, Graduate programs. So all of these graduate programs, Clarke CS and math students are able to um, get in. They compete. I had a student that was doing the 3-2 engineering program as well, which is also popular. So they did 3 years at Clarke, and then went to Columbia for 2 years for the engineering program. And I asked him, how well prepared did you feel you were? And so he wrote back. He said, I was pleasantly surprised. I showed up and I feel like I was actually better prepared than the students who had been at Columbia all along. So that made me feel pretty good that he came out of Clarke and then was very happy with what he had done at Clarke.